Hey, what's up everybody? Chris back with another Proto Tech Tip. And for today, we're gonna quickly dive back into SolidWorks to discuss how to properly model your sheet metal flanges to allow for what's called overbending. This is gonna be a relatively quick one, so let's get into it. So at Protocase and Protospace MFG, we revolutionize your workflow and simplify your part sourcing with the world's fastest custom manufacturing. We build your custom sheet metal and machine parts and enclosures in 2 to 3 days, offering a full in-house one-stop shop for materials, components, and finishes. We make the process of bringing your design ideas to life really simple. If you're not fully proficient in CAD modeling, you can use our in-house CAD design software called Protocase Designer. Or you can download a template from our template generator and import it into your CAD program of choice to finish customizing. Or simply just utilize our design services. For a lot of you, SolidWorks is your program of choice to design custom parts and enclosures, so that's what we're going to focus on today. Now before getting into this quick SolidWorks tutorial, let's talk about overbending in general. So overbending is what happens when you need to bend a part to a certain angle and the machinery that's used to bend it actually has to bend the angle of the flange past the degree that you're looking to finish at. Now, once the machine overbends, it actually springs back into the desired position. Now, what happens is this can sometimes cause issues when certain models are not designed properly to allow for this. So, let's open up SolidWorks so I can properly show you how to model for overbending. Let's say that we have a simple L bracket that needs a bent flange on one side. You can see when I pull this flange off to the left side, it's going to leave it in the default position. The bottom of the flange is parallel with the adjacent face. If you can imagine overbending this bracket past 90 degrees to spring back, the bottom of that flange could actually crash into the adjacent face, causing a deformed part. So how do we solve this? Well, it's actually simple. We place a small angled cut on the bottom of the flange edge so that once it bends past 90 degrees, the angle will allow for space. Let's go ahead and do a sketch on the face of that flange. We've tested over the years and found that a 5-degree cut extrude worked well. Now let's draw a small triangle and constrain it with a 5-degree angle. Let's go ahead and cut that through the flange. The result is a flange that has a nice angled edge that allows for a safe overbend and spring back, resulting in a good part. So I briefly talked about Protocase Designer earlier. With Protocase Designer, our manufacturing constraints are directly integrated into the software itself. If you choose to start with a template and design with Protocase Designer in the future, you can only make what we can build, which significantly speeds up the design to manufacturing process. So give it a try. The link to download Protocase Designer is in the description below. So one more thing before I let you go, it's important to know that if you don't account for overbending in your design, our engineering and design services team will flag this and then suggest changes to your model, or we can actually make those changes for you. The biggest thing here is to know these design tips in advance, to reduce that back and forth with revisions, and we can get your design to manufacturing as quick as possible. So that's it for today's tech tip inside SolidWorks. It was a quick one, but a super important design consideration to remember going forward. Take care, until next time.